Mars might be our next home, but how do we plan to feed ourselves there? The Martian surface is toxic, dry, and hostile to plant life. The idea of growing food on Mars sounds like pure science fiction, but NASA and researchers around the world are working to turn that fiction into reality. But can we actually farm on a planet that has no soil, no liquid water, and is bombarded by deadly radiation? The answer is far more complicated than Hollywood movies make it seem. If humans are going to settle on Mars, they can't rely on Earth forever. Shipping food across space isn't just expensive and slow, it's unsustainable. A successful colony on Mars means being self-sufficient, and that starts with figuring out how to grow food in one of the most hostile environments imaginable. But before we talk about solutions, let's break down the problems. Mars isn't Earth. It doesn't have fertile soil, breathable air, liquid water, or a stable climate. It's a world where temperatures can drop to -80 degrees Fahrenheit or -62 degrees Celsius at night, where the air is poisonous and where the sun's radiation bombards everything unprotected. Farming in this environment is like trying to grow crops on the moon, but worse. One of the biggest challenges is Martian soil, or lack thereof. What covers Mars isn't soil in the way we understand it. It's called regolith, a mix of fine dust and crushed rock that has never supported life. Unlike Earth soil, it lacks organic material. No dead plants, no decayed animals, no essential nutrients that crops need to survive. In short, it's lifeless. And to make things worse, it's toxic. Martian regolith contains perchlorates, chemical compounds that are deadly to plants and dangerous for human consumption. So, how do we fix the soil? Scientists are exploring several methods to make Martian regolith safe for farming. One idea is burning out the toxins using high temperatures, but this requires a lot of energy, something that's limited on Mars. Another method is washing out the perchlorates using water, but water is one of the scarcest resources on Mars. So, a more promising approach involves bioremediation, using bacteria to clean the soil. Some Earth bacteria already feed on perchlorates, breaking them down into harmless byproducts. If we introduce these microbes into Martian regolith, they could gradually detoxify the soil, making it safe for crops. This process has already been used on Earth to clean polluted environments, and now researchers are testing whether it could work on another planet. But removing toxins isn't enough. Even if we clean up the regolith, it still isn't real soil. It's just dust and rock. Plants need nutrients to grow, and Mars doesn't have any. On Earth, soil is alive. It's filled with microbes, fungi, and decomposing organic matter that cycle nutrients and keep plants healthy. But on Mars, there's no natural source of nutrients. This means future Martian farmers will need to build their soil from scratch. One option is to use human waste, a concept popularized by the movie The Martian, where Mark Watney fertilizes his crops with astronaut feces. While this could work, it's not a long-term solution. Human waste alone doesn't provide all the nutrients crops need. Instead, researchers are looking at ways to artificially enrich Martian regolith using minerals, compost, and even synthetic fertilizers. Some experiments on Earth have already shown that Martian soil simulants, dirt with a composition similar to Mars, can support plant growth if they're properly supplemented with nutrients. But soil isn't the only problem. Plants need water, and that's another major challenge. Mars has water, but it's mostly trapped as ice beneath the surface. There are also salty brines in some regions, but they're not safe for drinking or farming without purification. The planet's thin atmosphere means liquid water boils away almost instantly, making traditional irrigation nearly impossible. So how do we get water for farming? One potential solution is melting subsurface ice and filtering it for use. NASA's upcoming missions aim to map underground ice deposits, making it easier for future settlers to extract and use it. Another idea involves harvesting atmospheric water, similar to technology already used in deserts on Earth, where machines pull moisture from the air and condense it into liquid. Even with access to water, there's another massive hurdle: radiation. Mars doesn't have a magnetic field to protect it from cosmic rays, meaning anything left exposed on the surface is constantly bombarded with high-energy radiation. For humans, this means an increased risk of cancer and radiation sickness. For plants, it means genetic damage, stunted growth, and failed crops. To solve this, farming on Mars can't happen in the open. Instead, plants will have to be grown underground, inside radiation-shielded greenhouses, or within pressurized domes. These controlled environments would protect crops from extreme temperatures, lack of oxygen, and the deadly radiation from space. This brings us to how plants will actually grow, because soil-based farming isn't the only option. Scientists are exploring hydroponics and aeroponics, methods that don't require soil at all. In hydroponic systems, plants grow in nutrient-rich water instead of soil. This method has been tested in space stations and extreme environments on Earth, and it allows crops to grow faster with less water. However, hydroponics requires constant monitoring, and if a system fails or gets contaminated, an entire crop can be wiped out instantly. Aeroponics, on the other hand, grows plants using mist. Instead of submerging roots in water, nutrients are sprayed directly onto them, using even less water than hydroponics. NASA has already tested aeroponics for space missions, and it could be a game changer for Mars farming. But here's the real question. What crops should we grow? Not all plants can survive in extreme conditions, so researchers are focusing on hardy, nutrient-rich crops that require minimal resources. Some of the best candidates include potatoes, adaptable, calorie-dense, and capable of growing in poor soil. Lettuce and spinach, fast-growing and require little space. Legumes, like beans and lentils, great for nitrogen fixation, improving soil quality over time. Algae and fungi can grow in complete darkness and provide essential nutrients. By carefully selecting which plants to bring, future Martian settlers can maximize food production while using as few resources as possible. And believe it or not, we're already testing Mars farming on Earth. In the Atacama Desert in Chile, one of the driest places on Earth, scientists are growing crops in extreme conditions to see how they might survive on Mars. Desert greenhouses, lunar soil simulants, and controlled environments are being used to experiment with Martian farming techniques, helping us prepare for the real thing. So, will we be farming on Mars in our lifetime? Maybe. The technology is still developing, and there are huge challenges to overcome. But the fact that scientists are already growing food in Martian-like conditions is a sign that this dream is becoming more realistic than ever before. If we ever want to live on Mars, we need to figure out how to feed ourselves first. And the work happening today is bringing us one step closer to making that a reality. Farming on Mars might seem impossible, but humans have a history of turning the impossible into reality. We've built underwater farms, grown crops in deserts, and even grown food in space. Mars is the next frontier, and with each experiment, each breakthrough, and each step forward, we get closer to seeing the first farms beyond Earth. The future of Martian colonization depends on solving this challenge, and whether it takes a few decades or a century, one thing is clear. When humans step onto Mars for good, they'll need to bring more than just technology. They'll need seeds, soil, and a plan to grow a new world. Farming on Mars might sound impossible, but scientists are already making it closer to reality. From detoxifying soil with microbes to building sustainable greenhouses, every breakthrough moves us one step closer to growing food on another planet. What do you think? Will we see Martian farms in our lifetime? Or is it just a dream? Let us know in the comments below. And if you enjoyed this video, don't forget to like, subscribe, and hit the notification bell so you never miss an update on the latest space discoveries.